Hi guys. So we're going to try using these videos out to see if this is going to help people get through this. There's some struggling. So this is the first question I picked. This is question 5 off from lesson 3. Now what they're looking for is the voltage right here. They're looking for the voltage across this resistor. But let's go through the process of what we want to do. We don't need to do all this, but let's go through the process of how we should be going about this just to get the repetition in. Okay. So the first thing we want to do is, you see I've got these two circled. These are in series. So the first step that we want to do whenever we come to one of these is combine all the series circuits that aren't affected by anything else. Two resistors on the same branch, prime candidate for it. So every time we do these, the strongest thing I would recommend is simplifying it out, just drawing it this way. So we got these two, 12 and 18. So the resistor R3 and R4, essentially that's going to be looking at 30 ohms. 12, 18, 30 ohms. And we got 15 on this branch, 15 ohms of resistance. And then 10 ohms on that resistor. So the next step that we want to do is we want to combine these two. So we're just going to use the reciprocal formula. Which, when you combine these two out, what's it going to give us? You got 10 ohms on this branch and 10 ohms on that branch. Now, if you don't understand part of these concepts, get a hold of me. Let's do some worksheets. Let's figure it out. We can still work in small groups, and I'm willing to come down and help guys, in smaller groups, whatever they'll allow me to do to help you guys get through this. But this is the toughest stuff we've done all year. Not necessarily this problem, but they're going to get a little bit tougher than this. So, since we have all this information, they gave us the amperage. We know we got an amp flowing through here. That and that, we have our I and our R. I is constant through here. So we know by using I times R, 1 times 10, that we're getting 10 volts across that resistor. Which also means, this isn't part of the question, but it applies, we're getting 10 volts also on this resistor. And since we know voltage is constant in a parallel circuit, we know we're applying 10 volts to this one, and 10 volts is going to drop partially across each of these two. Both of these rungs are going to see 10 volts. Just something to keep in mind as we go forward on these.